Okay, so let us start. Yes, Sam, you are saying something. Okay, so can we start? Let us start today's session. Okay, any doubts if you have on, see, we are still in the process of completing these topics, but you can tell any type of questions we will discuss. This nobody will tell, okay, everybody will come and teach and go. They will not be ready to address your issues. So here in this platform, I am giving you free, like everything, so that you can ask, interact, and solve your doubts, understand what is the thing you are lagging, any kind of questions you can ask, right? So that is what. Let us start with one very important question. That is a question coming in NEET most of the times, right? So let us say that there are two inclined mirrors, right? So there are two inclined mirrors, and let us say the angle between them is 60 degree. 60 degree is the angle between the two plane mirrors. Now the question is, if there is a ray coming, let us say there is a ray coming, we are saying that there is a ray of light which is coming like this way, and this ray of light is coming at some angle. Let us say they have given this glance angle. This is called glance angle, and glance angle is given, let us say, it is given as 30 degree. Let us say like this. Okay, it is given. Now the question is that after some number of reflection, this ray will retract its path. Retract its path. So okay. So after how many after how many after how many reflections this ray this incident ray retracts its path. This one question. Okay, this is mirror 1, this is mirror 2. Can you solve this? Can anybody solve this? Now, if you are NEET student or JEE Main or JEE Advanced student, if you have attended the last class, you must know the formula, and if you do not know the formula, you must know the technique. By that technique, we can quickly solve. What happened? Suddenly that went away. Might be some issue was there. Okay, let me again draw that question. This angle was 60 degree. This is mirror 1, this is mirror 2, and a ray is coming at an angle of 30 degree. After how many reflections? After how many reflections will this incident ray retraces its path? Retraces its path. This is one model of question I am giving. Another model of question also I can give afterwards. First you solve this. Anybody can solve and give the answer. 23. After 23 reflections it will go. Are you sure? Monish, Chhatresh, Lalit, you must be able to do that. If you are not doing, then what is the problem? Tell me. Otherwise all the class is going to be a waste. That's all. From my side, what is the problem, you tell me, and from your side, what is problem, that also you tell me. 3. Number of reflections should be 3. Okay. Anyone else? Come on. Yes. Number of reflections. How many reflections? Yes, Monish, Chhatresh. Lalit, see, you can please keep your video on, because see, this interaction otherwise is not going to be very much fruitful. Please keep all of your camera, video camera on, and interact and ask questions. Please. Yes. Three. Three reflections. 23 reflections. 23 reflections happen. After how many reflections will the incident retraces its path? 23 reflection. Yes. Monish, Chatresh. Oh, Kishore. Come on, you fix your answer. 23 or 3, what it is? Come on. If I give some option, you will try to put. But you must know. Without option, you should solve. Then only you will know what it is. Yes. Chatresh. Hmm. What is the answer? Kishore. Huh? How much? Sam. 23. Lock. No, what is this? Come on, that what is the use of this class then? So many, I'm trying to take all the topics in detail. Why are you not responding or giving answers? Hmm. Atres, after so many days, your face I'm seeing. Uh, your health is okay, Chatres? Hmm. Okay, then any idea? No? Monish, Kishore, formula I have derived. That formula, if you remember, you can solve. If you do remember that formula, you can solve. But if you do not remember that formula, there is a technique within 1 minute you can solve. It's not going to take much time. Okay. So I hope you people are watching the videos the whole night. Sometimes it goes to 11:30, 11:40. Also, I'm making it so that you can watch. You don't have to wait for 1 year to do that again. You know, if you don't do that again, you have to put so much effort. Now also you put effort, afterwards also put effort, but if you put effort now properly, then later it will become easy. Okay. So you are anyway studying, you are making hard work, but do it properly. Hmm. Okay. No one can give 23. Sam, let us see that. So if you remember, let us say I don't remember formula, I forget, generally I forget that. So remember the technique, how to do that. I will do the mirroring of these images like this, like mirrors I will make like this. So each of these angles will be 60, 60, 60, 60, like that it will go. Remember that 60, 60, theta, 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 whatever is that. And this ray, which is the original ray, which is coming like this way, this ray I will take going like this way, like this, and retraces its path means what? Retraces its path means that angle where it is going to hit. Let us say at this point it is going to hit. So if it is hitting at 90 degrees, then only it will retraces its path. It will come backward, right? So retraces path means that particular angle will be 90 degree. That particular angle will be 90 degree, and suppose this particular angle is 90 degree, starting from this point as 1, 2, 3, let us say this is n. Okay, n it is where the angle has become 90 degree, and remember this is 30 degree, so this is 30 degree, right? And how many angle this total will be there if it is going, so from 1 to 2, that is 1 theta, 2 to 3 that is 2 theta. So 1 to n if you go, 1 to n if you go, that will be n minus 1 theta. So this angle is going to be n minus 1 to theta. Theta means 60 degree here. Okay. So sum of these angles of this triangle, sum of the angle of this triangle is 180 degree. All of us know that. So that's what this angle which is 90 degree plus this angle which is 30 degree plus this angle which is n minus 1 into 60 degree, that is going to be 180 degree. So from here now you calculate. So n minus 1 into 60 degree is equal to what? Is equal to, this is subtract, this is 120, so 180 minus 120, that becomes 60. Yes, that becomes 60. Afterwards what happens? Calculate. Correct? Check out this. So n minus 1 is equal to 1. So n becomes equal to 2. N becomes equal to 2 means here and here. Two point of incidence. Note that there are 2 point of incidence. 2 point of incidences are there. So if you remember, suppose if the ray is coming, here is 1 point of incidence and after that it is second point of incidence. That's all. Here it is going to be 90 degrees, so it will retract its path. While retracting, while returning, it is again hitting here. So this is the third time it is hitting. That's all. So total number of reflections is 3. Total number of reflections are 3. Number of point of incidences are 2. Yes, that is the answer. That's the answer, 3. Number of reflections is 3. Number of reflections is equal to 3. That's what it is. Okay. So you can solve any type of questions, any type of model of questions come, you can solve. Now in this type of questions, there is a also a type of question that can come, that this ray which is coming here, it is hitting here. It may become parallel to, while after reflections, it may become parallel to one of the mirror. Okay, so let us take that example, model question. Suppose two mirrors are there and this is angle theta, let us say. So a ray of light is coming like this, a ray of light is coming like this, and the question is, what should be this angle theta, so that after some number of reflections, maybe one reflection, two reflections, whatever it is, or let us say two reflections, okay, this ray must become parallel to the same mirror. Let us say this is first M1 and this is second. So after reflections, it will become parallel to this mirror. Let us say it become parallel means it can become parallel to this, like this. So final ray has to come like this. Final ray, final ray that become parallel to first mirror. Now this type of questions, how do we solve? After nth reflection, they will also give after nth reflection. After nth reflection. After nth reflection. Okay. What should be the value of I, that after nth reflection this will become parallel to the first? Then do calculate that. Final ray become parallel. There are some questions, you look. See, if you have solved really questions, you will find such model of questions in your, either your NEET modules books or JEE main JEE. You will find such questions. They will give this angle and they will say that ray is coming like this. After some reflection, it become parallel to either that mirror or this mirror. What should be the angle of incidence I? Okay. What do you think? How to calculate that? Same approach, same approach we can use, right? Let us say this mirror become parallel to this. If it becomes parallel, so what do you think the angle with the mirror will be? What will be the angle with the mirror? Suppose it is coming parallel. Okay. So with this first mirror, it is making 0 angle, and with second mirror, it will be making same angle theta only. It will be coming like this way, right? It's coming like this way. It is it is coming parallel to this mirror. Okay. So think about it. Same manner you think. Suppose if the ray is going like this, I consider like this way only. This ray is going in this manner, and I will make these mirrors like the same approach. I will take. You know, same approach I will take. Theta, 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 theta. I can consider theta, 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 theta. So let us say that this is the point, nth point starting from 1, 2, 3, n. Okay, n point. Then at this point, it when it so nth reflection is happening. That's the nth reflection. In that reflection, this is making how much angle with the mirror. If you see glance angle, of course, this is the glance angle only, right? This angle is nothing but the glance angle, isn't it? So it is making with this mirror, second mirror, that angle theta is the glance angle. Or with the first mirror, angle uh, it makes angle 0 degree or 180 degree, because it is going to be parallel to the first mirror. With second mirror, it will be making angle theta. So suppose if you consider like the same approach, so this is I, so this is I, and this angle is n minus 1 theta. This angle is n minus 1 into theta, right? This is I. Now this is like the glance angle. If you remember, these angles are the glance angles, not the deviations. So if you consider this as the glance angle, I can take that glance angle as theta only, isn't it? Because it is coming with it. I am taking that this is hitting this mirror. Last point, it is hitting this mirror, and with this mirror, this is making the glance angle as theta. So this is angle theta. So now try to take the sum of all the angles. So sum of all angles is theta plus I plus n minus 1 into theta is equal to 180 degree. Try this. What do you get? So when you open this one, theta will get cancelled. So I plus n times theta will become 180 degree. So I will become 180 degree minus n times theta. Yes. Can we write like this? Isn't it? Because what is glance angle? Let me also make sure that are we doing correct. Because glance angle is what angle? Angle with the mirror. So are we talking about this angle? Let me make sure. Are we talking about these angles? Or these are the glance angle? Might be this is the glance angle. So are they talking about this as theta? So if this is theta, then this angle which we are talking is 180 minus theta, right? So let us check again. I think it should be 180 minus theta. This angle. This angle should be 180 minus theta. Okay. So here I will put it as 180 minus theta. This angle, because these are the glance angle. This I, then this one, this one, this one, right? Okay. So change it here. What will happen? This will get cancelled. Then what do we get? What do we get? I think little difference answer will come. Check how much it is coming. Then what will happen? Then I plus n minus 1 into theta minus theta or is equal to 0, right? Because that got cancelled. Then what will be I? I will be, this is minus n minus 2 theta. So you take that side, 2 minus n theta it will become. That means n will not be greater than 2. Maximum it will be 2, right? Maximum it will be 2. Is this condition correct or not? This we can do only when we check some questions on this model. So please try to find out if any questions are on this model, then we can verify that, right? And they will give, I think, here nth reflection. So definitely in this case, n cannot be more than 2. Maximum it will be 2. If it is 2, then I will be 0. I will be 0. Correct? N cannot be 3 and n cannot be 4. So there will be some limitations, I think, in this case, if we are considering this way. So check out this whether this model is correct or not, because we are taking this angle as the glance angle. So glance angle will be changing like this, and this is the last angle. So with the mirror, we will be making theta because it has to become parallel like that. So we can consider this case theta. And if we take this theta, we are getting this condition on. Might be question will change. Something else they may give. Okay. But whatever it is, whatever they give, this technique which I have given, any type of questions can be solved on inclined mirrors. Yes. Here, Patrice, Sam, Monish, Lalit. Hmm. Okay, then done. We'll move next forward with another questions. Anyone having any doubts in this? I think we have discussed up to reflection lenses. We have not started. How much we have covered last class? Yes. Last class, how much we have covered? Topic. Last topic was what? Inclined mirrors only we have discussed. Refraction we have not discussed. Retracting the path already we discussed. Number of images we discussed. Okay, so we'll start with refraction today. Today we will start with refraction. Let's start with refraction. Done, Lalit. Have you noted this? So I tell you that I made some paper for grade 11, but people told that it is very difficult. Then I dropped the whole paper. Almost everything I dropped it because they told that students cannot solve problems. That is the way we are treating the students. They cannot solve problem. What is this? They cannot solve. Why they cannot solve? You can solve now. Should I tell that you are weak? That is not very good. I don't consider that. You can solve questions, but the thing is that you have to work hard. Teacher also have to work hard. Both if work hard, then only things can happen. Right? Otherwise, it is everyone is weak. Otherwise, everyone is weak. If they don't work hard, they will become weak. Correct? No? You have to work. Many good questions I plan to give, but the thing is that it dropped. So when we can give good questions? 1 year after? After 1 year, there won't be anything. Okay, anyway, let us go that. So, grade 11 also batches you can attend and you can ask questions. My target is not to finish any topic or syllabus because anyway I am not obliged to finish anything. I only want to finish your doubts. Whatever doubts is there, we will do that. Okay. Anyway, some sequence I am taking. I will cover that sequence gradually, but there is no time limit. Okay. But you ask doubts, attend classes, ask doubts. Topic wise doubts you can ask. Okay. Let us move next. So refraction, we will start refraction, and there are many good questions on this reflection also. If you go look at the questions, there are many wonderful questions on reflection. You need to really work out problems if you have, and also give the test. I think I created 6 tests on reflections. I don't know how many of you have given. Reflection itself, I created 6 tests. Okay. Anyway, let us move. So we'll go for refraction, refraction, refraction of light. So what is refraction of light? Refraction of light is the bending of light. Light rays is going and the ray will bend. When it will bend, what is the condition? So that we will see. So condition for refraction. So first is, let us say that there is a boundary. It's called optical boundary. Optical boundary. Optical boundary. And there are two mediums. This is medium 1 and this is medium 2. And there is a property called refractive index N1 and 2, which we have studied in electromagnetic wave. Refractive index is the ratio of speed of light in vacuum by uh, speed of light in medium. And refractive index is also given as root under mu r epsilon r. If you remember that in electromagnetic wave chapter, mu r is magnetic relative magnetic permeability, epsilon r is relative electrical permittivity, which is also called dielectric constant. So most of the time, if nothing is given, mu r is taken as 1, epsilon r dielectric constant of medium they will give. Okay, we can calculate. But anyway, now this chapter ray optics, we have to use this property refractive index. So what happens? It is a optical property. Refractive index is a optical property. Just like every object or substance has electrical property, thermal property, physical property, like that optical property. Optical property means how it interacts with light. Okay. So when light passes through a medium, it reduces the speed of light by some factor. That factor is the refractive index. Okay. So now suppose if a ray of light is coming, what kind of ray? Oblique ray. First of all, you must know that this is a oblique incident ray. Oblique incident ray. Oblique incident ray is coming here and it is hitting here, and then this ray will deviate from its path. It will not continue its path, it will deviate. It may go either towards normal or away from normal, anywhere it goes. Okay, so this point is the point of incidence. This is the point of incidence. Point of incidence. This is incident ray. This is incident ray, and this is reflected. Refracted ray. Refracted ray. Okay, and this angle with the normal. This is normal here. This is normal, and this angle is angle of incidence I. This angle is angle of refraction r. So I is the angle of incidence, and r is the angle of refraction. Refraction. So then, what is the law of refraction and what is refraction means? So refraction means that if an oblique incident ray is coming, oblique means it is neither this way parallel to the surface nor perpendicular to the surface. If it is perpendicular, then it will go without bending, and if it is parallel, then it is going in the boundary itself. It is not going from one medium to another medium, right? So ray of light has to go from one medium to another medium. Then ray of light has to be incident like this way, making some angle I. Okay, then in that case the ray will bend. Okay, that is what it is. So this is what, if they ask in your exam, that is how you have to write in your statements, that if a ray of light is going from first medium to second medium and the ray of light is an oblique ray means it is neither parallel to surface nor perpendicular, then that ray will bend after going from one medium to another. This process, this phenomena is called refraction of light. Okay, that's what it is. Okay, so next is what is the law of refraction? That is the law of refraction. Let us discuss the law of refraction. So law of refraction means 2 points in the law is there. First point is that n1 sine I is equal to n2 sine r, and second is, this is also known as Snell's law, and second is that incident ray normal and refracted ray all lie in the same plane, okay, like this it is, all lie in the same plane. So Now, but this law, all of you know already in grade 10th, you might have studied that. But let us see in vector form. So, vector form means, suppose if you take ray going like this way, and this is the angle of incidence I, and this is the angle of reflection R. So, if there is this incident ray, let us write a unit vector in this direction as EI cap, and a unit vector in this reflected direction is ER cap. And let us take a vector any direction you can take. Suppose I take a unit vector in this direction, normal direction, this is normal, En cap. Okay, then what will happen? I can write this angle. How to write the angle? This How do we write I? Means sin I. You know, cross products give sin I, dot products give cos psi, cos theta, and cross product gives sin theta. You know that. A cross B, JB sin theta, right? So suppose if I take the cross product of this EI, EI is anyway going like this. So EI vector, how much EI vector will make with the normal? Okay, should we take this normal or that normal? How to take that? That is also important, because we can take normal in this direction, normal in this direction. If I take normal in this direction, then ER cross will be coming this way, and then I have to also take EI cross this. But then angle I need to look at that. What is the angle between them? Okay, both the things we have to look at that. So can we take En like this? If I take En like this, then EI cross En will go that way, and ER cross, and it will be better. Okay, it will be better to take in this direction, opposite direction. Okay, so let us take a vector, normal vector in this direction, in the first medium. Okay, we are taking in the first medium En cap. So this is a normal unit vector in this direction, remember this. Okay, now I am going to take cross product of EI and En cap. Note En cap. En cap is like this way, En cap is like this way, and EI cap direction, if you see, EI cap is coming like this direction, but its direction will go like this. Okay, direction you can take like this way, EI cap. So if this angle is theta, this angle is I, then it will be 180 minus I. Okay, so let us take cross product of this EI cap cross En cap. So EI cap cross En cap. Take cross product. So cross product is magnitude, multiply magnitude into this angle becomes sine 180 minus I. Okay, sine 180. Let us take that. So sine 180 minus I, and of course there will be a unit vector which is going like clockwise. Clockwise means it will be going inside, so that vector n cap is cross. I'm writing that as cross. So n cap is going vector inside the plane, right? So what I will get from here is ei cap cross En, this cross, that sine 180 minus theta is same as sine I. So sine I into n cap. Okay, it's a vector. Now similarly, if I take the same diagram, if you see here, En cap is this direction and Er cap is this direction. So what is the angle between this? Because this is R. So if you take Er cap and En cap, okay. So note that this angle is R. So this angle becomes 180 minus R. So again here you go in the same direction like this clockwise. Here also we are going like clockwise only. So here also we are going clockwise. So take ER cap cross EN cap. When you take this cross again, 1 into 1 into sine 180 minus R will come. Correct? 1 into sine 180 minus R will come. And then direction is again cross only. Cross product is a vector. So that will give same n cap. So from here we can say that ER cross En cap is going to be same as sine R, and of course this is magnitude, and this is unit vector. Now let us try to write the law of reflection. So law of reflection says that n1 sine I is equal to n2 sine R. Now I will write sine I. I can write sine I as that. So what I can do is, if I multiply, anyway n cap are unit vector, they can cancel out. So if I multiply this side, I multiply vector, because this is a scalar, note that this is scalar, I multiply vector n cap. So this side also I can multiply the vector n cap. Remember, this multiplication is n cap vector multiply by this. Here also n cap multiply by this. Because these quantities are same, so it doesn't matter. But here this I cap, sin I n cap, we can write as ei cross en. That is what is the law. Very important, concept it is. Because many questions can be solved from this. So ei cross en. Difficult low-level questions can be solved. Okay. Similarly, n2 er is small or capital R, whatever it is, doesn't matter. Refracted ray is cross en cap. Okay, so this is the law of refraction in vector form. This is the law of refraction in vector form. Law of refraction in vector form. Okay, that's the law of refraction, which can be used to solve even tough type of question. Now see, I will tell you how to solve question. First of all, you should know that ei cap, en cap, er cap, en cap, these are all unit vectors. They are all unit vectors. And in the question, they will give you ei cap, en cap, and they will ask you to calculate er cap. The unit vector in the direction of refracted ray. So you assume er cap is xi cap, yj cap, zk cap, assume, and xyz you need to solve. So one thing you already know, that it's a unit vector, so er cap means root under x square plus y square plus z square is 1. One equation anyway you know. Then another equation will come by doing the cross products. From these equations, you will be able to calculate x and y, and z you will calculate from another equation. There was a question, when a student asked that question from Physics Galaxy to us. Initially, I was thinking to derive some equation like this. In module, it was given. Okay, so I was thinking in terms of dot, because dot will give cos, right? Cos theta or cos I, cos r can be given. But cross you need to take, because when you take cross, right? When you take cross, the cross of, because all the three vectors are perpendicular. Note that this is important thing. All the three vectors are in the same plane, means what? That also you can say. So this is the first law of reflection, first form of the law of reflection. Second form, that all these lie in the same plane. That means the triple cross product. Scalar triple product. That means ei, ER, and EN. This is going to be 0. Because when three vectors are perpendicular, A cross B dot C will give 0. This is nothing but, what is this? Triple. This cross this with dot En cap is 0. That is what it is. Okay. So this is called scalar triple product. Scalar triple product. It is scalar triple product. And this condition represents the collinearity, coplanarity, coplanarity, coplanarity. Coplanarity means all the three vectors are in the same plane. Because if three vectors are in the same plane, the cross product of two, cross product always give perpendicular. So cross product of two become perpendicular to the entire plane, including the third one. So that's why this cross product of 2 and dot with 3, that is become 0. Cross product of first and second becomes perpendicular to the plane of the three vectors. So it is perpendicular to each of them. So it is perpendicular to third also. So cross product is perpendicular to the third one, so it's dotted 0. Okay, so that's the condition for this. I hope you got it. So this is all about the law of refraction. Law of refraction, that is called law of refraction. Also note that in this law, sometimes just symbol this they use, that is called relative refractive index. Relative refractive index. Relative refractive index means refractive index of first medium, refractive index of first medium with respect to second medium. It is denoted like, refractive index of first with respect to second means n1 by n2. Okay, n1 by n2, and sometimes it is written as n21. n21 they write. n21 means n1 by n2. Okay, in textbooks they are writing like this. Okay, so if you study the this n1 sine I is equal to n2 sine r, so I can write this sine I as n2, or sine I by sine r ratio is n2 by n1. This can be written as refractive index of 2 with respect to first. This can be written as 2 here and first here, like this. Okay, like this we can write. So this is refractive index of second with respect to first. Okay, so sin I by sin R ratio gives the relative refractive index of second with respect to first. Theory, writing in theories. Okay, nothing is new in this. Okay, then next, now we will see refraction through spherical surface. Okay, refraction happen like this, plane surfaces. Okay, here also there are some model of questions like bird and fish. Let us discuss that also. Bird and fish type of problems. Okay, write this. Okay, let us move next. Bird and fish problem we will see. Before that, going into bird and fish problem, let us say that this side is n1 and this is n2. Okay, and let us say some object is there here. This is an object, and this object is at some distance below it. Okay, some distance will be x distance below it. Okay, and I want to find its image from this. This means there is an observer here. Let us take an observer here, and that observer is exactly above this. Okay, note that the observer is lying in this vertical line only. Okay, so observer is somewhere here, and this is the eye of the observer. How to draw this eye? I forgot. Um, like this way. This is the eye of the observer. Okay, this is the eye below. Okay, so this is how light is going into the eye of the observer. So observer or the eye of the observer is near normal. This is called near normal observation. Near normal, near normal observation. Near normal observation. So near normal means observer is almost near the normal, very near to normal distance. So now let us find out that if this distance is x, where will be the image? This observer, how he will see the image of this? Okay. So let us take some rays. So you consider some rays going like this way, and assume that This is either going towards or away, any direction it will go. Let us consider that it is going towards, like this it will go. This is angle I, this is angle R. Note that this I, R are very, very small. That is what we have to take. All these rays are paraxial rays. So, paraxial rays, paraxial rays, paraxial rays, remember, I are very small, very, very small. Okay, so very, very small means what? We can write I as sine I, we can write I as tan I. We are free to write like this. Okay, so let us apply the conditions. So apply what? Apply the condition. What is the refraction conditions? So first of all, we have to see where the image comes. So I will draw dot like here. Similarly, one more ray I will take. This side I will take one ray, and here this ray also will go this way somewhere here. So this ray also dot here. So this image will form here. Okay. So this is the object and this is the image. Of course, this image is not a real image because the refracted rays has diverged. So when you extended them backward, then only you are able to make this image, right? When we are extending backward, then only we are getting the image. Okay, so note that if this is I, right? So this is also I, right? This is also I, and this is R, so this is also R. Okay, and let us say that this distance is some distance. Let us say B. Okay, so there is a right triangle getting formed here that we should know. There is a right triangle getting formed. Similarly, there is a right triangle here also. This one. Two right triangles we can see. So let us apply this tan I calculation. So this is the depth of the image. Let us call this distance as x dash, and object distance is x. What is x here? I will remove this x from here. So what is x? X is the distance of object from this. That means this distance. This distance is x. Okay. So x is the distance of object. X dash is the distance of the image. Here this ray diagram is like it is going from denser to rarer because it is going away from normal. Okay, right. So let us apply this condition. So let us find out tan I. Tan I is what? Tan I in this triangle is B by X. What is tan I? So tan I is same as I only because very, very small. And similarly, what is tan R? Tan R is B by X dash. Again, this angle is small, so R is B by X dash. So we got R, we got I. Then now apply N1 sine I is equal to N2 sine I. So from here we can say that sine I is very small I, so sine R is very small R. So now I we will substitute as B by X, and N2 R we substitute as B by X dash. So B get cancelled. So X dash becomes N1 by N2. Sorry, N2 by N1. What is X dash? We are getting now. So X dash becomes equal to N2 by N1 times X. That is the law, not law, it's important result for near normal observation. Okay. So x dash is equal to N2 by N1, and see that here if I take N2 is rarer and N1 is denser, then this is going to be a fraction smaller than x, right? So this x dash is going to be smaller than x. Okay, that means if there is a object inside water, it gets shifted upward. This image looks to be forming near the surface. Yes, are you getting this? That is also called apparent depth. Okay. Done. All of you noted this. So this is the apparent depth. This is the formula for apparent depth. Apparent depth. And note that x and x dash lie in the same side. Suppose, for example, if this is object here, so its image will lie in the same side. Suppose this is water and this is air. Suppose this is the object is, let us say, fish. Object is a fish. Object is a fish. So its image will be forming here. Okay, that is the image of fish. Fish image. Image of fish will form here. Fish is here object. This fish is object, and this fish is image. Okay, or you may write f, that is better. So if this fish is like f, its image form f dash here. So if the distance of this fish actual distance is x, then this distance will be x dash, and this x dash will be given as n2 by n1. N2 air is 1, and let us say n1 of this water is mu. So you will get as 1 by mu into x. So x dash becomes x by mu. Okay, that's what it is. That's the proof. That is approach apparent depth. So if anybody try to look from, look from top, it looked like that the fish is near to the surface and he tried to catch, he will not get anything because actually that is the image of the fish. He will try to catch fish, but nothing is there. Only water will come. Okay. So fish is below, but the image of fish looks higher. Okay. Clear. So this type of questions. Now, suppose if I want to see the bird, let us try to now understand bird. Suppose this is air and there is a this is water and there is a bird here. Bird is B. Let us say this is the object. Note that this is the object now. Bird is the object now. Okay, bird is the object. So you need to consider this as the first medium. Okay, because object is always whichever side is object, that you have to take as first medium. Remember that. This n1 is going to be 1 and this n2 is going to be mu here. Okay. Now, suppose if I consider this as, let us say this is y. Okay. Bird is there. Where is the image of that? Use this formula, same formula you use. X, instead of x, you can use, if you want, you write x, no problem. Should not be confusion. Okay. If you want x, you write as x. So what will be x dash? X dash is n2 by n1 times x. Now what is n2 here? Note that n2 is mu here. N1 is 1. So mu times x. Now mu is greater than 1. So now you will see that this image of bird will be coming here. B dash. Okay. So this image distance x dash is nothing but mu times of x. This is what we need to note. Okay, so the image of this bird goes still higher away from this surface. So if the object is in rarer medium, its image goes away from the surface, and if the object is in denser medium, its image goes closer to the surface. That's important point to note. Clear? All of you got it? Yes. So calculations on this can be solved. Now suppose they will give that there is a bird, there is a fish, both are there. They are trying to catch each other. Some velocity they will give. No, there are questions on that. So you can definitely work out problems on that. Okay, you can work out questions on that. So do you have any doubts on this topic? Satrish, Monish. So, why are you not asking doubts? Why do you not have doubts? Are you not solving problems, questions, or you are getting clear everything, or you are solving only easy questions? That is what is done. Total Google you can do, but the thing is that that will not be very much. That will not develop your skill, right? See, your skill will develop when you interact with different. If it is better to ask some of your friends if you don't know, but Google, if you instantly ask, it will give you the answer, but you will become too much dependent on that. Okay, so better you spend some time thinking and keep those doubts and ask in the class, or you ask if you instantly want it, then you may discuss. You can message me also, or you can ask with somebody. Google, that is not better actually. In the sense of using it, the only people like researchers they use Google. That is better because when you search in Google, you'll get so many options, so many links you will get, and then a person who is doing research, while I was working in this IIT, that time we used to Google Scholar. We had Google Scholar is for researchers. In Google Scholars, we used to type keywords and so many research journals papers we used to get, and we used to go through everything. But for students, means it may create a distraction and it may make you weak. That is the thing. Okay. So we try to ask doubts to teachers. That will be better. Hmm? If that is not available, then you can go. But if teachers are available, then you can ask them. Hmm? Right? Okay, Satres, honest. Then we'll see in the next class tomorrow. We'll see that whether we can do or not because not sure. Maybe you will be working out for your exam, right? You will be working questions for your exam, right? So any doubts if you have, we can ask. Okay, you can send and we will see that. Okay, fine all. Okay, bye bye. We'll see you next class. Good night all. Yeah.